అమ్మో! అమ్మో! అమ్మో!
హ్మ్.
అందరికి కష్టమే ఇగ.
a single GPU or more than one GPU. Coming to the next question raised by Yash. In supervised learning, after splitting data into training, validation, and test, and after evaluating the model on test set, how can we provide feedback or improve the model without retraining it entirely from scratch, since retraining can be costly? So I think we don't. Yeah. So in this case, yeah. So your model has to be generalized enough. In a sense, let's say when you train the model, and then you have a validation data set as well. So you basically try to improve the model uh, on validation data set itself, or it could be using like cross validation. Yeah, and then you use test data set to evaluate the model. But if you want to uh, provide feedback or improve the model further, like I feel you'll have to train the model from scratch only. So Aryant, what do you think about this question? So
Sorry, what was the question? Can you just
this is
summarize?
this is raised by Yash at 2-1,
Okay,
201.
in supervised learning, after splitting data in training validation.
What original algebra? Data is highly embarrassing.
Okay, without retraining. Maybe we can add like a sort of sampler or associate weights to
నా ఫోన్ తీసుకురా
each sample
నా ఫోన్లో తీసుకురా ఏడు
based on the loss outcome. I think if let's say the loss is very high for a particular sample and if this prediction is wrong, we can say that the weight of the sample is low, and while predicting it, while utilizing it for a newer sample, we can reduce it weights. Maybe something can be done in a k nearest neighbor sort of ML technique, where we know that the sample is sort of an outlier by looking at its loss, and then when we are computing the neighbors, we can sort of eliminate it while computing the neighbors. So this could be one approach.
Okay, thanks, Aryan. So now I'll move on to the next question. Apart from accuracy, what else drives your decision of a model selection between a simple model like logistic regression versus a complex model like gradient boosting through XGBoost? Okay, so apart from accuracy, I mean, it depends what problem we have been solving. Depending, let's say if this is a binary classification sort of problem, we basically use other metrics like precision, recall, and then we based on that we see how the model has been performing in a sense, whether this is a high bias or high variance. And let's say if this has a high bias, we move on to the more complex models. While in case of high variance, let's say we are using a complex model, then we'll move on to the a simpler model. Next question is, what is Gemini impurity often why is Gini impurity often preferred over entropy in practice? And in what cases might entropy be the better choice? No, as such is I mean, I don't think that Gini impurity is preferred over entropy. People use either of these. And I don't think we can have a like either Gini impurity is a better choice or the entropy is a better choice. It depends which model has been performing better. So let's say in one model we use Gini impurity and we see the performance on test data. And in another case, we build a model using entropy and then see the performance and then decide which one could be a better choice. A bit off next question is a bit off topic, but do Amazon provide Cairo ID license or for development, especially for applied scientists? Yes. I mean, once you are hired, like for the employees or like for the applied scientists, you can have a number of license. I mean, depending on, uh, I mean, those should be compatible or let's say tie up with Amazon. You get the uh, these things. Next question is Amazon must be getting huge amounts of structure, semi-structure, and unstructured data. How do you automate and prioritize feature engineering selection across various sources? So, I mean, feature engineering something can be done for any type of data structure, like whether it is structure, semi-structure, or unstructured. And actually, I don't understand this question. Looks like how do you automate and prioritize feature engineering
including high dimension data sets.
and selection across various sources?
What tool do Amazon use
I
to
mean, it depends on the problem you have been working on, and depends which data set would be used there, whether it's structures and structure, unstructured, and then you decide. So, yeah. Next is let's say we have short text description about people's skill and experience, but no pre-existing label category. How could we first create those labels and then use supervised learning to identify the most suitable role or category for each without manually writing rules or using big AI model LLMs? Yeah, so for labeling, I mean, somehow, let's say, either you'll have to use human auditors to get the first set of labels, those could be limited. And then, as I mentioned, you can use semi-supervised learning and keep doing that. And otherwise, like let's say we have, I mean, human auditors, which are going to be very uh, uh, costly. Then in that case, we can use LLMs because now we have good LLMs which can also provide labels. Next question is boosting can improve accuracy but also risk overfitting noisy data. Boosting can improve accuracy but also risk overfitting noisy data. How do you decide the optimal number of boosting rounds and control for noise amplification, especially when the weak learners themselves are high variance model like decision trees? Yeah, so boosting is something used for reducing the bias, and for deciding the optimal number of boosting rounds is something we'll have to iterate over because this is more like a hyperparameter, cannot be fixed at the first hand itself. And to control for noise amplification, I think we'll have to try with other hyperparameters as well. Yeah. Aryan, would you like to take after this? From Sulekha at 201.
And you're on mute. If you're talking, we can't hear you.
Yeah, sorry. So the next question is what else expect the traditional ML theory is required to be a successful applied ML engineer or scientist at Amazon or anywhere. So theory is one part. Second thing is keeping your fundamentals strong, both the theory and the practical aspects. You should know the math behind any ML technique, as well as how to implement that in the real world. And another thing is playing around with your data. The more you know about your data, the better applied scientist you will become. And The general guideline is keep playing around with the new techniques that come up in the research, so you stay relevant and would be able to solve more problems easily. Next is, why is gradient boosting often preferred over ADA boost for regression problems? Um, so gradient boosting is more of a broader class of boosting techniques. It's like an advanced version of boosting techniques which combine boosting along with gradient space optimization. So I would say it's a more advanced version of ADA boost, uh, as it tries to optimize in the gradient space itself, while ADA boost is focusing on reducing the errors in a sequence. Gradient boosting does that in the gradient space. Next question is, generally, what I did in my ML journey till now is selecting different models, losses by hit and trial. So industries, are we required to know all these complex formulas? If yes, how do we determine which loss function to be used for which scenario? So the first part of this question is, yes, do we should know the formulas and the derivations of all these complex formulas and ML techniques. We use them on daily basis here to improve the inherent bias present in these mathematical formulas, and change it accordingly as per the problem statement we solve. And the basic loss function, basically how do we determine which loss function to use? It's entirely dependent on the problem statement. If you use a regression, you may try to use this mean square error loss, while for a classification problem you try to uh, optimize the cross entropy loss. If it's an entirely different type of setup, such as contrastive setup, you use different loss function. So it entirely depends upon your problem statement and the data you are dealing with. Next, we have, can we use logistic regression or linear regression instead of decision tree to predict if a customer will return a product on Amazon? If yes, how would it work? And what would be the pros and cons? So the underlying thing while using a model is basically the data. If the data is linearly separable, definitely we can use logistic regression or linear regression. If the data is not linearly separable, we might need to use advanced algorithms such as decision tree, neural networks, etc. In real life scenarios, rarely we get linearly separable data, so we tend to focus more on advanced algorithms such as decision tree or boosting trees. So it entirely depends upon your data. The pros and cons is basically these advanced algorithms are basically a more high latency, takes more time to predict something, while this linear regression models, since they are simple, they just need very uh, few latency. So these are basically the pros and cons of using these models. Can we get the PPT? Yes, you might be able to get how to be relevant in AI ML field with these rapid changes. Uh, it's true that these changes are rapid, so you just need to first identify your interest. Uh, for example, if you are interested uh, more in, let's say, the computer vision field, you keep tracking what are the latest papers coming out. in the field using the tools such as maybe Google Scholar or Archive, and also read papers relevant to your project or the problem statement you are trying to solve in this in the domain. And but before that, keep your fundamentals strong so that it would be easier for you to adapt to these changes, because the fundamentals still remains the same, which are we are covering in this ML summer school. uh, Moving on to the next unanswered question. When deciding between simple algorithms like logistic regression and more complex ones, what factors guide the choice in real world application? Like I said earlier, it entirely depends upon your data. If the data is linearly separable, we tend to use this simple algorithms. If they are not, we choose this more complex models, deep neural networks, boosting, etc. Next, we have how are these formulas for the model used? Can you please explain with examples? Formulas for different models. So these formulas are tend to used for reaching to an implementation stage. So we can think of our computer as a big programming machine, where we just have to like basically learn something from the data. So basically, we where each data point is your data, we just tend to, let's say, if you want to find the mean or the variance of a particular data of a huge list, you just need to use the calculator. You cannot do it manually. So these formulas are basically the generic expressions in order to compute this sort of statistical, build these statistical models, and based on these generic formulas, you tend to arrive to a different model. For example, these decision tree models use this entropy measure or Gini measures, which is calculated by some formula. And when we like do the implementation of these formulas on the computer, we tend, and based on some branching, which we also think of it as in if else, we we tend to calculate a decision tree. Now, this decision tree would be useful in your prediction. So that is how we and start with some assumption. Then we tend to arrive its formula, and then we use these formulas to build a model, and that can be implemented in the real world. So how this whole cycle from coming from theory to the practical implementation is done. Next, we have when a brand new product is added to the Amazon with no reviews or clicks, how does self-supervised learning help recommend it to the customers? So when a brand is added, it's like we have its title, we have its mm, different descriptions, different images. We we do test our models on this sort of out of brand uh, data, so that whenever a new brand which we have not seen previously is added, we our models are capable enough to handle this sort of scenarios. uh, so it's entirely when we do the evaluation, we sort of eliminate new brands, so that whenever a new brand comes in real life, we are able to handle. So it depends on how we are creating the train, validation and test set, and we sort of remove some brands which are present in the test set and which are not present in the training set. We try to make them mutually exclusive so that our evaluation is as per the real life setup. Next, how do we choose between models like naive Bayes, KNN for a new problem if we don't know the data distribution? If you don't know the data distribution, the best approach is follow the standard ML pipeline. Basically, split your data into train, validation, and a test set, and try to measure the performance of each of these models on your validation set and the test set. And whatever works whatever model is giving you the best results should be uh, that would be your best model to choose from. How do you select the best cost function? So yeah, it's entirely dependent on problem statement and the data. There is in ML there is no thing like intuitively you can do to select the best uh, hyperparameter loss functions models. You just need to experiment more and more with your data so that uh, the best ROC and AUC please. Um, so ROC and AUC, ROC basically it's a curve which where between true positive rate and false positive rate, and it helps you identify if your model is able to distinguish between the two classes you have. And basically on one side we plot true positive rate and one side we plot false positive rate based on different threshold values, and we take the area. If the area is high, we can say that with less threshold we are able to get more true positive rate as and less false positive rate. So if the area, it only happens when the area is high. So when you compare two different models on on this curve, uh, uh, whenever you are getting more area, it means that that model is able to classify uh, between the two classes more better than the first model. And with the same threshold on uh, that particular on those particular models, if we are getting more true positives and less false positive. So if your problem statement is such that you have to decide between true positive and false positive, then definitely it is uh, one of the one of the parameters, one of the metrics we use for evaluation, and it's generally used for, I think, imbalance classification problems where you have to focus more on one class more, such as true positive, and consider less of the false positive. Next we have how do we classify, where we will be using type of metrics, precision, accuracy for others. So again, it's also problem statement dependent. Accuracy is used when the data uh, is sort of balanced. We have equal number of positive and negative samples. Precision is when you want to focus more on the true positives, such as spam classification data set. So yeah, it's depend upon of your problem statement. When the data is noisy or change over time, how do you decide between improving the data or making the model more adaptable? So improving the data is sort of a hard problem statement. Generally, first thing a scientist would try is to make the model more adaptable by assuming that there would be noise over the data, and we can do it by by making a good split across our training, validation, and test set. Uh, because so that since we know that it changes over time, we can sort of have a test set which is out of time, so that whenever a new distribution comes in the data, our model would be should be able to handle. So I think the preference here would be to make the model more adaptable by doing the proper splitting of the training, validation, and test set, and finding the right model uh, would give that would give the best numbers or metrics on the test data. Need of ML in the LLM era. So yeah, definitely there is a need of ML. Without ML, you cannot actually build an LLM. The training which is required to build such a huge LLM is comes first from the ML. The cross and drop belows which you might have studied today is the basic loss function which is used in the pre-training stage of the LLMs. The the linear regressions, the linear projections, which you have studied, and all of the things which you might will be studying in this ML summer school will be required in sort of building these LLMs and focusing. Then you can, if you are like well versed with these ML techniques, then only you will be able to understand how these ML LLMs are working. What is the recruitment process for such queries? Maybe you can contact ML Summer School email ID. In the real world where distribution shift fast, how do we maintain balance without constant retraining? There are different techniques. One is make your model adaptable by doing out of time testing. Second is advanced techniques, using advanced techniques such as curriculum learning or continuous learning, so that your model is able to adapt to these distribution shifts. So they are specialized topics which require separate field of study, but the underlying basics of all of these techniques are same. They use these sort of loss functions models in between. It's just the training process is sort of different uh, in these uh, in these models. What is overfitting and how do we prevent it? Overfitting is whenever your model is sort of cram the your entire training data, uh, so it is not able to generalize well on your test data. Uh, you can think of it like an exam, with an example, like you learned all the materials you have studied, but you are not able. Whenever a question comes, you are not able to answer because you have crammed the your materials so well, because so that whenever a new question come you are not able to answer it. So you can prevent it by various techniques such as regularization, uh, or one is regularization for sure. Maybe increase your training data set, uh, or you can sort of uh, make your model less complex so that it does not learn the model well. So there are different techniques that by experimentation you can try to prevent this overfitting. Next, we have in large scale systems like Amazon Prime Video recommendation for detection. How to determine optimal recall trade off, especially when business goal like customer experience and class impulse output thresholds in these different directions. So yeah, first we build for a fraud detection system. First we build or a recommendation. First we build a model. Uh, uh, Taking the example as fraud detection, because it is an imbalanced problem, we sort of uh, try to first optimize the ROC, AUC, precision, recall, etc., and try to build a model that has highest precision, highest recall, and highest ROC. And then we take these models to business teams where uh, a minimum threshold bar is decided for a treatment, and we try to sort of optimize, uh, basically trying to find the perfect threshold uh, where this minimum threshold is met. So it's first we do some sort of ML engineering, try to build the best model, and then take to the customer experience or business team so that we can utilize this model for creating the business impact and achieve our business goals. Maybe Sanjay, you can take from there.
Okay, so which question you were at?
Srivat.
Okay,
At
Srimat is something you have
202.
already covered.
No, no, you have to go.
Okay, so good afternoon, sir. I have a question in ensemble learning that when deciding between bagging and boosting, what key characteristics of the dataset should influence the choice? If both works well, would you ever use them together in a stack model or better generalization? Okay, so I mean, so which method to use, bagging or boosting, uh, based on the data set is something we cannot figure out in advance. So if you want to try, like, I think we'll have to try both of these uh, separately and see how the performance has been coming out